Welcome again to another video. Now we are going to see another type of differential equation, which is a Ricati differential equation. And let's get started. A Ricati differential equation could be written in the form of y prime plus px y plus qx y squared is going to be equal to, let's call it mx. As you can see here, we have y prime and we have our function, which is y and y to the power of 2, so y squared. So let's see a particular cases if qx is going to be equal to 0, which implies that, let's call it 1, which implies 1 to be, so we don't have y to the power of 2, so it's going to be a linear differential equation. And if mx is going to be equal to 0, which implies that 1 is a Bernoulli equation. As you can see here, this is a particular case for Ricati differential equation. So a Ricati differential equation could not be solved unless we have a particular solution, and let's call it y0. Y0 is a particular solution for our equation, our Ricati equation. So when we have y0, we are going to search for yp, let's call it yp, and the summation of them that is going to be y, and y is a general solution. Y is a general solution for 1, which is Ricati equation. So we can easily prove that if y0 is a solution and yp is a solution, so their sum is going to be a solution also for our equation. I'm not going to do that in this video. We are just going to learn the method how to solve this kind of differential equation. Let's now we're going to see the method. As I told you that we need to have a particular solution, or we can call it just y0, which is verify the equation. So, which is verify the equation is a solution for 1, which means that if we replace for 1, sorry. Yes. Which means if we replace y by y0, which means that y0 is going to verify the equation. So it's going to be y0 prime plus px y0 plus qx y0 squared is going to be equal to mx. So as you can see here, this is a particular solution. So, and yp is a solution, also a solution for the equation. So, and y is the general solution. So when we replace y in the equation, we're going to get y plus y prime, sorry, plus pxy plus qxy squared is going to be equal to mx. As you can see here, we have a system and y is equal to y0 plus yp. So we're going to replace y, we're going to repeat, yes, this is the same equation. And we have y is y0 plus yp all prime plus px times y0 plus yp plus qx times y0 plus yp all prime is going to be equal to mx. As you can see here, this is equal to mx, and this is equal to mx, so this is going to be equal to this. Now what should we do is to subtract the equation, let's call it number 1, from 2, and we're going to obtain the following. We're going to obtain, let me rewrite first the second equation. It's going to be y0 plus pxy0 plus qxy0 all square is going to be equal to mx, which is equation number 1. Equation number 2 is going to be y0 prime plus yp prime, yes, plus pxy0 plus pxyp plus qxy0 squared plus qxyp squared. I need more space, plus 2qy0yp is going to be equal to mx, and this is equation number 2. As you can see here, by subtracting, or we can by subtracting 1 from 2, so it is 2 minus 1, we're going to obtain the following. Y0 prime is going to cancel with y0 prime, pxy0 with pxy0, qxy0, and m is going to be cancelled with m. So we're going to obtain yp prime plus px yp plus qx yp squared plus 2qxy0 yp is going to be equal to 0. Now we have obtained this equation, so it is I'm gonna do some simplification. No, I'm gonna just order them to see that we have a Bernoulli differential equation. So it's gonna be yp prime plus, yes, px plus 2qx all times yp is going to be equal minus qxyp squared. As you can see here, this is a Bernoulli differential equation, and you know how to solve a Bernoulli differential equation, and this is the method how to solve a Ricati differential equation. As I said before, that we need to have a particular solution, or by you can find it in the question, or by observing if it's an easy one. Of course, sometimes it's difficult to observe some difficult functions, or since a difficult equation can contain a difficult function. What I mean by difficult function, it is difficult to observe the function. Yes, and now just to remind you that we have Ricati is going to be Bernoulli, and Bernoulli is going to be a linear. Wherever you are, you need to use this rule. Now we are going to solve just one example, since it is the same as Bernoulli and linear. We are going to give you a particular solution. Let's see the example number 1. It said so verify that, let me rewrite, y 2y prime cosine x is going to be equal y squared plus 2 cosine square x minus sine square x. As you can see here, this is our rx or mx, or what we have called. So this is a Ricati differential equation, and he said that verify that sin x is a solution for this equation. If we replace sin x, let y0 is going to be equal to sin x, when we get the derivative, is going to be y0 prime is going to be cosine x. So when we replace it here, it's going to be 2 cosine square x, and this side and in this side is going to be 2 cosine square x. Since this is going to be sine squared x, is going to be, and we need to subtract sine square x, so it's going to be 0, and we will end up with 2 cosine squared x. And this is an easy question. The second question, he said that solve this differential equation. So let's get started. As you can see here, we have 2y primes, 2y prime cosine x is going to be equal y squared plus 2 cosine squared x minus sine squared x. As you can see here, now we need to put y prime by itself. So the rule is said we have y prime here by itself. So it's going to be y prime. So we need to divide by 2 cosine x. It's going to be 1 over 2 cosine x y squared plus cosine x minus sine squared x over 2 cosine x. As you can see here, it is a also, yeah, it is a Ricati differential equation. We didn't do anything. Now what should we do? We should use, let y is going to be y0 plus yp. So we're going to obtain y prime is going to be y0 prime plus yp prime. So we will end up with y0 prime plus yp prime is going to be equal 1 over 2 cosine x times y0 plus yp all squared plus cosine x minus sine squared x over 2 cosine x. This is the first equation. Since I said that y0 is going to be equal to sine x, since we have seen that in the first question, so it's going to be y0 prime is equal to 1 over 2 cosine x y0 squared plus cosine x minus sine squared over x over 2 cosine x. So as you can see here, we have a system of equations. So we need to find yp, and we have y0. Y0 is known and yp is unknown. So let's simplify more and more. We're going to get y0 prime plus yp prime in this side, 1 over cosine 2 cosine x y0 squared plus 1 over 2 cosine x yp squared plus 2 times 1 over 2 cosine x y0 yp and plus cosine x minus sine square x over cosine x to cosine x. Yes, and we will repeat right in the second equation as it is. By subtracting 2 from 1, we are going to obtain the following. This is going to be cancelled, and this is going to be cancelled with this. We're going to obtain that y prime p, yp prime is going to be equal to 1 over 2 cosine x yp squared plus 1 over cosine x y0 yp. And yes, so, and as you know that y0 is going to be a sine, so sine x, so we're going to get yp prime 1 over 2 cosine x yp squared plus sine over cosine is going to be tangent, so we're going to write tangent x y p. As you can see here, we have a Bernoulli differential equation. Let me rewrite it: minus tangent x yp is going to be equal 1 over 2 cosine x yp squared. As you can see, this is a Bernoulli differential equation, and we know how to solve a Bernoulli differential equation. Let's solve it. So what we need to first to divide by yp squared. So sorry, we're gonna obtain yp prime over yp squared minus tangent x yp to the power of minus 1 is going to be equal 1 over 2 cosine x. Let's substitute as t is going to be equal yp to the power of minus 1. So t prime is going to be minus 1 yp prime yp to the power of minus 2. So minus 1 is going to be here plus. So we are going to obtain minus t prime, yes, minus tangent x t is going to be equal 1 over 2 cosine x. So this is a linear differential equation, as you can see here. Multiply it by minus, we're going to obtain the following. Yes, this is a linear differential equation. So, and you know how to solve this kind of differential equation. So, we are going to calculate the exponential of the integral of tangent x dx. So we're going to obtain exponential of integral of tangent is going to be ln 1 over cosine x, and it's going to be 1 over cosine x. So it's going to be 1 over cosine x, yes. So by multiplying the equation by 1 over cosine x, we're going to obtain 1 over cosine x t prime, yes, plus tangent x over cosine x t minus 1 over 2 cosine squared x. So as you can see, this is a product of the derivative of the product of two functions, which is 1 over cosine x and t. It's going to be equal to minus 1 over 2 times 1 over cosine square x. So as you can see here, by integrating the both sides, we're going to get 1 over cosine x t is going to be equal to minus 1 over 2. And the integral of 1 over cosine squared is going to be tangent x. Since when we get the derivative of tangent, we're going to obtain 1 over cosine squared x. We're going to see this in the next chapter, which is integration. We're going to see some methods how to integrate this kind of functions. And we're going to, yes, plus c. So by multiplying by cosine x, we're going to obtain t. It's going to be equal to minus 1 over 2. And tangent times cosine, it's going to be sine x. So it's going to be sine x plus c cosine x. So, and t is equal to yp to the power of minus 1. So yp is going to be 1 over minus 1 over 2 sine x plus c times cosine x. And now, as we said before, that the general solution is going to be y is going to be equal to y0 plus yp. So it's going to be sine x plus 1 over minus 1 over 2 sine x plus c times cosine x. Now, this is the end of the video. I hope that you have understand all what we did, and see you in the next video.